ReachMD XM157, each hour at this time, presents a special series, Focus on Men's Health.
Finally, an explanation of the gender difference in hepatocellular carcinoma. You're listening to ReachMD XM157, the channel for medical professionals. Welcome to the Clinicians Roundtable. I'm your host, Dr. Maurice Pickard. And joining me today is Dr. Arlin Rogers. Dr. Rogers is a doctor of veterinary medicine, Ph.D., at the Division of Comparative Medicine at MIT, Cambridge, Massachusetts. Thank you very much for joining us today.
It's a pleasure to be here.
Recently, in the Journal of Cancer Research, you published that maybe for the first time, a genome study may explain the gender effect in carcinoma of a non-reproductive organ, such as the liver or, indeed, possibly the bladder, which also has a gender difference. Could you tell me, first of all, the method that led you to this conclusion?
Well, it was a study in mice. It was in a mouse model, and we work on infectious liver cancer here in our group. And we wanted to see, and in our mouse model, as well as in humans, there's a strong male predilection for liver cancer. In humans, it's more than 2 to 1. In some parts of the country, it's up to 6 or 8 to 1, male to female. And that same gender ratio applies to rodent models. And so we wanted to ask whether affecting the male hormone signaling would influence liver cancer outcomes in our infectious model. Now, many people have shown in younger mice that if you castrate males, you offer partial protection against liver cancer. And also, if you ovariectomize females, they get a slightly increased rate of liver cancer. But no one's ever looked at it in mature animals. And so we wanted to reproduce the human scenario. Most liver cancer cases in humans affect older adults. Many times the diagnosis of viral hepatitis, which is the leading cause of liver cancer, is not made until well into maturity. So we wanted to model the human clinical scenario and not intervene in these mice until they had reached maturity, rather than doing these interventions around the time of puberty, which is when most studies perform them. We hypothesized going into the study that if we castrated mice, there would be some protection against liver cancer, and that if we gave them a powerful androgen agonist, dihydrotestosterone, which is the most powerful natural androgen receptor ligand, that we would increase the rates of liver cancer in these mature mice. And we found to our surprise that none of our treatments had any effect whatsoever when we waited until maturity to institute them.
So you were left with the idea, certainly, that hormones didn't seem to make a difference. What then was your conclusion, and where did you then turn for an explanation?
Well, that's a good question. We were left scratching our heads for a while because it's always unfortunate when you perform a 2-year study and your original hypothesis is disproven. So we had to go around looking for an alternate explanation. And that's when we really dug deep into the molecular aspects of our model and started looking at gene expression patterns, and in particular cytokine analyses, things related to the immune system. And we started to notice this interesting trend where the males that had progressive disease appeared to lose the maleness, if you will, of their liver. I perhaps should have mentioned earlier that the male liver is very different from a female liver, both in humans and in rodents. At puberty, the male liver is told to be male through a complex endocrine cascade that eventually results in big boluses of growth hormone being released from the pituitary, and the liver synthesis those boluses and becomes a male liver, and in the absence of those boluses, the default pattern of femaleness is retained.
Females do get growth hormone, though, but in a different way.
Exactly, and this is true both in rodents and humans. The female pattern of growth hormone release from the pituitary is more continuous. There are small spikes, of course, throughout the day, but it's more or less continuously released. Whereas in males, especially after puberty, under the influence of testosterone acting centrally in the brain, that pattern results in a bolus of growth hormone release every few hours, followed by long periods of almost undetectable circulating growth hormone. In females, there's continuous but lower levels of growth hormone release from the pituitary, and the liver senses those differences. And so a male liver knows it's in a male body because of the way the growth hormone arrives at it through the blood circulation. And in the absence of those male signals, the default female pathway is retained.
Is this what you've called in your article liver gender disruption?
Well, liver gender disruption is a term we came up with to describe the scrambling of gene expression in the diseased liver. The growth hormone that I previously mentioned will cause changes in transcription of a large number of genes. In fact, in our mouse model, more than 10% of genes were differentially expressed between intact and castrated males. And this is also held true in other models that a large number of genes are differently expressed in the male liver versus the female liver, but there's a pattern there. And so a male liver will have a certain pattern of gene expression, and a female liver will have a different but also predictable signature, if you will, of gene expression. And if you do large-scale gene studies, such as with microarray, you can tell a male liver from a female liver just by looking at those genes. What we saw in our males with progressive liver disease and cancer was that that signature was lost. When you looked at the liver of a male with liver cancer, you couldn't tell if that was a male or a female liver. It was completely scrambled, and that was what we called liver gender disruption. The liver no longer knew what gender it was.
And would this lead to some type of chemical aberrations in the various metabolic pathways that take place in the liver?
Absolutely. A large number of these genes, as you might imagine, that are differently expressed between males and females are related to hormones, of course, hormone metabolism, also lipid signaling, inflammation. A lot of metabolic pathways that are differently regulated in males and females were affected by this process. And our working hypothesis now is that when you lose that balance, there is no longer proper metabolism, proper immune function in the liver. It doesn't matter if it's a male liver or a female liver, if it's in balance and working properly. But if the liver no longer has that balance, no longer knows what gender it is, if you will, then it's unable to properly respond to challenges, and the disease spirals out of control.
If you're just joining us, you're listening to the Clinicians Roundtable on ReachMD XM 157, the channel for medical professionals. I'm your host, Dr. Maurice Pickard, and I'm speaking with Dr. Arlin Rogers, Doctor of Veterinary Medicine at the Division of Comparative Medicine at MIT, Cambridge, Massachusetts. And we're discussing his interesting and maybe groundbreaking work that genetic abnormalities may be the explanation why the incidence of hepatocellular cancer is so much higher in males. At the University of San Diego, they've also published some data that seems to be related in that it involves interleukin-6. Would you comment on this? Is this all tied in with what you're doing?
It's very closely related, yes. Michael Karen at the University of California at San Diego has done a lot of groundbreaking work in liver cancer, especially related to the component of inflammation. And this is a real excellent time to bring up the point that there's really two factors, I think, that account for the gender difference in liver cancer. And Dr. Karen's work is focused on the inflammation side. He did much of his groundbreaking work related to NF-kappa B, which is a central regulator of inflammation, and has branched out from there, showing the role of inflammation in various diseases, including liver cancer. And so he showed very convincingly that interleukin-6 is a very important component of the male response to a chemical liver carcinogen, and that there was a different expression pattern of interleukin-6 between male and female mice. And when he used interleukin-6 deficient mice that had been knocked out for the IL-6 gene, suddenly that gender difference was lost. Males and females had the same incidence of liver cancer in the absence of IL-6. And he's shown in this and previous work that this is largely related to cells of the immune system, particularly in the liver. The resident macrophages called Kupffer cells are the major source of IL-6. And he's shown in related studies that the inflammatory component is a major part of this gender disparity. We're looking more on the other side of the coin, which is the hepatocyte side. And so I think it's important to note that if you take male mice and castrate them at an early age, they get less liver cancer than sexually intact mice will get, but they don't get the same low rate as female mice. And conversely, if you take a female mouse, remove the female reproductive organs, that female mouse will get higher liver cancer than an intact female mouse will get, but never approach the male. So there's more than just sex hormones at play here. And this is where we think the hepatocyte side comes in. If you castrate a male mouse, that male mouse doesn't suddenly have estrogen circulating. It just has decreased androgens. And so we think that estrogen is part of the story. We think the IL-6 is certainly tied into estrogen, and Dr. Karen's work has certainly shown that a lot of these IL-6 and other cytokine responses are regulated, at least in part, by the estrogen receptor. So we think that estrogen is definitely involved directly in protecting females from liver cancer. We think there's more, though. We think that there's this imprinting of liver through this other mechanism, through the growth hormone signaling that makes a male liver more susceptible. And we think that both arms are playing a role, both the immune system and the hepatocyte differentiation.
Is it possible the liver gender disruption that you've talked about is affecting the manufacturing of interleukin-6, that indeed such a mouse or mice that are affected in this way make more interleukin-6? Female mice do not.
Absolutely. And the crosstalk is very close, as you might expect, between the hepatocytes and the immune cells of the liver, including both the macrophages and the resident natural killer T cells and other immune cells that reside within the liver. Separating them is really an artificial phenomenon we do in the laboratory. In real life, both arms are going to be talking very closely to one another. A disturbance in one arm is going to affect the other. And so, absolutely, it may be that the way hepatocytes talk with the macrophages affects interleukin-6. It's also possible, and this is a hypothesis we intend to address, that interleukin-6 helps to make the male liver more male. None of the studies that have been done so far have determined whether interleukin-6 knockout mice are able to masculinize the liver properly to begin with. And so definitely it cuts both ways, and we think both arms are going to be very important. And hopefully in the future, our studies, Dr. Karen's studies, and other laboratories will come together and put it all together.
I'm concerned that in the 70s we saw a tremendous incidence of hepatitis C due to transfusions and drug use. Are we possibly sitting on a time bomb that in the next few years, hepatocellular carcinoma, which hasn't been that frequent in the United States, will suddenly almost reach possibly a marked increase in incidence?
Well, we're not just sitting on the time bomb. It's already started to go off. Liver cancer is the fastest rising cancer in the United States. As you mentioned, compared to things like lung cancer, breast cancer, colon cancer, it's much lower in this country versus in parts of Asia and Africa where liver cancer may be the leading cause of death among older adults. In this country, certainly, historically, it has had a much lower incidence, but it's rising dramatically. Hepatitis C is a big reason for that. In the 60s, 70s, and 80s, before we knew what hepatitis C was, many people were infected to the point where now up to 4 to 5% of adult Americans are infected with hepatitis C. It's the number one chronic bloodborne pathogen in the United States. We're seeing the front end of the iceberg from that. We would expect perhaps after that population progresses through over the next maybe 50 years, and we now have better screening methods for hepatitis C, that might decline. But unfortunately, there's another wave coming right behind the hepatitis C wave, and that is diabetes and obesity. So liver cancer isn't going to go away anytime soon. It's going to continue to rise, and it's a growing medical problem that we need to address.
I want to thank Dr. Arlin Rogers, who's been our guest today, and we've been discussing the difficult problem of coming up with a reason and an explanation and therefore a treatment for hepatocellular carcinoma. I'm Dr. Maurice Pickard, and you've been listening to the Clinicians Roundtable on ReachMD XM 157, the channel for medical professionals. To listen to our on-demand library, visit us at reachmd.com. If you have comments or suggestions, call us at 888-XM157. Thank you for listening.
Listen all month as ReachMD XM 157, the channel for medical professionals, presents a special series, Focus on Men's Health.